Hello, welcome everyone. Now question number 2 of exercise 2.3. This is the first question of number 2, class 9 general maths. Remember, here the question is given whether gx is a factor of px. So in a division, you remember, in a division, we know this is, here it is given, this is gx and this is px. Okay, so means we have to divide this by this, and if you get a number, and remember, remainder should be 0, in that case we can say gx is a factor of px. Okay, so it can be done by another method, that is called that is putting the values. Here you write remainder theorem. Okay, so you write let gx is 0. Gx is given x plus 1 is equal to 0. So x is equal to minus 1. Now here you put the values. 2 into, in place of x you write minus 1 whole cube. You can write px, no problem. Here in place of x we are putting minus 1. 2 into minus 1 whole cube. Plus here you write minus 1 whole square minus 2 into minus 1. Then it is given minus 1. Okay, now you see 2 into minus 1 cube is minus 2 plus 1 plus 2 minus 1. So 2 to cancel, 1 also cancel, that is equal to 0. If you get 0, you write therefore gx is a factor of px. Okay, in the same way, here also given px is this, gx is this. You write, suppose we are considering x plus 2 equal to 0. It means what? It means by x plus 2 we have considered this can be completely divisible without remainder. So it means x equal to minus 2. Now here you write px is x cube plus 3x square plus 3x plus 1. In place of p you write minus 2. You will get minus 2 whole cube. You see, x is minus 2, so we are putting x equal to minus 2 in each part. Minus 2 square plus 3 into minus 2 plus 1. Then you will get minus 8. Minus 2 square is 4, 4 3 is 12. You write here 12. Minus 6 plus 1. It can be written as 12 minus 8 is 4. 4 and 1 is 5. 5 minus 6 is minus 1. So we are not getting 0 here, therefore you write px or gx is not a factor of gx. Actually, yes, gx is not a factor of px. Okay, next again we have to check whether x minus 3 is a factor of this. So again you write let x minus 3 is equal to 0. Therefore we can write x equal to 3. Now you write px is x cube minus 4x square plus x plus 6. Now in place of x you put 3. 3 cube minus 4 into 3 square plus 3 plus 6. 3 cube is 27. 9 4 is 36 plus 9. 27 plus 9 is 36 minus 36, that is equal to 0. So you just do the calculation according to your method. You see 3 cube, if you don't and know the value of 3 cube is 27, then you multiply 3 into 3 into 3, then you see what will happen. If you multiply them all, 3 square means 3 into 3, that is 9, 9 into 4 is 36. Now here plus 3 and plus 6, I have added these together. So here you see 27 is also positive, 9 is also positive. So 27 plus 9 is 36 minus 36, that is equal to 0. So therefore you write, if you get 0, therefore you write gx is a factor of px. Now we have completed question number 2. Now suppose I want to do the question number 3 also. Question number 3 is given if x minus 1 is a factor of px, find the value of k. Find the value of k. You remember this part is common for all the question of question number 3. Here 4 questions are there. So this part is common for all. You read the question, if x minus 1 is a factor of px. So what is px? It is given here. Number 1, px is given x square plus x plus k. So since x minus 1 is a factor, therefore you write x minus 1 equal to 0, means x equal to 1. Now you write px is x square plus x plus k is equal to, it will be 0 because it is clearly given x minus 1 is a factor, means we can divide px by x minus 1. After division there will be no remainder, and that's why I have given the 0. Since there will be no remainder, therefore I have given 0. Now you put x equal to 1. 1 square plus 1 plus k is equal to 0. So you will get 2 plus k is equal to 0. So the value of k will be minus 2. K is minus 2. So 1 done. Number 2. Px is given 2x square plus kx plus root 2. Again we have to check whether x minus 1 is a factor of this. You write let x plus 1 is equal to 0 because it is a factor. Therefore you write x equal to minus 1. Now you write px is 2x square plus kx plus root 2. That should be equal to 0 because x plus 1 is a factor, means by x plus 1 if we divide this term, it will be completely divisible and there will be no remainder. That's why I have given 0. Therefore you write 2 into minus 1 whole square plus k into minus 1 plus root 2 equal to 0. So this can be written as 2 minus k plus root 2 equal to 0. Therefore, by side change we can write 2 plus root 2 is equal to k. So the value of k is 2 plus root 2. Number 2 complete. Another question number 3 of the same question number 3. Here px is given kx square minus root 2x plus 1. So here if you write let x plus 1 is equal to 0. Therefore we can write x equal to minus 1. Now you write px is kx square minus root 2x plus 1 is equal to 0. Because it can be divisible completely by x plus 1, there will be no remainder. That's why I have it in 0. Now here you write k into minus 1 square minus root 2 into minus 1 plus 1 equal to 0. So this can be written as k minus a minus a plus root 2 plus 1 equal to 0. So you will get k is equal to minus root 2 minus 1. So if I take minus common, it will be root 2 plus 1. So the value of k is minus root 2 plus 1. Another question number 4. This is the last one of question number 3. Here also we have to check whether x minus 1 is a factor of px. So px is given here kx square minus 3x plus k. So you write let x minus 1 is a factor. Therefore you can write x minus 1 equal to 0. Therefore x is equal to 1. Now you write px is kx square minus 3x plus k is equal to 0. So here you write k into 1 square minus 3 into 1 plus k is equal to 0. So k into 1 square is k minus 3 plus k is equal to 0. So you will get 2k equal to 3. Therefore k is equal to 3 by 2. Okay, 3 by 2. So these are the answer of question number 3. I hope you can understand and you can use it for your education purpose. And before completing my video, I am requesting all of you to please subscribe my channel and press the bell icon for the latest update. Thank you. Good night.